Good afternoon, everyone. We are going to continue our work with relations and functions. Today we're going to learn how to map functions so that we can determine whether or not it is a function. Actually, we're going to be mapping relations to determine whether or not it's a function. So you may recall that we were talking about relations and how there are domains and ranges. The domain is all of the inputs or all of the x values, and the range is all of the outputs or all of the y values. So for this particular relation that you see here, can you find its domain? I would suggest that we start listing in order from least to greatest all the x values, and that would be the domain. And then the range would be all of the outputs or all of the y values. That would be 7, 9, 1, 12, and 7. So there's an easy way to figure out whether or not this is a function. You may recall that I was talking earlier about it's a function only if each and every input produces one predictable output every single time. If it doesn't produce the same output every single time, if it produces two different outputs at any time, then it's not a function. Here's an easy way for us to work with it. We're going to map the function. So what we're going to do with all of these values in this relation is we're going to take every domain value and list it in a box. So there's my domain box. And I'm going to start placing all of my values from least to greatest in this box. So here we go. Next, I'm going to take all of my range values from each of these, and I'm going to list them in my box in order from least to greatest. And there they are. So now I'm going to map. I'm going to start actually mapping the relation between the inputs and the outputs. That means I'm going to draw an arrow from each one of these inputs, each one of these domain values, and from each of these I'm going to draw an arrow to its corresponding range or its corresponding output. So for example, negative 11 maps to the number 12. Negative 3 maps to the number 1. 2 and 5, 2 maps to 7, 5 maps to 9, and 13 maps to 7. So what we're going to do next is we're going to check to make sure that each of these input numbers, each of these domain numbers only produce one range number. So they can only have one arrow coming away from each one of them. So negative 11 checks just fine, negative 3 is okay, 2 works out just fine, 5 is okay, and 13 is just fine. So that means that this is a function. Because each one of these domain values only pointed to one range value, then this is a function. Now you may have noticed that over here, 7 has two different numbers pointing to it. That's okay. That still qualifies as a function. It's still a function. Even though one range number has two different domain values pointing to it, it still works out just fine. Let's try another one of these. We're going to consider this. Can you find the domain? And can you find the range? Let's go ahead and determine if it's a function by mapping. So there are all of my domain values from least to greatest. There's 1, 4, 16, and 25. Again, we took those from the x values, 1, 4, 16, and 25. And then my range numbers come from the y values. Those are the outputs. So negative 5, negative 4, negative 2, 1, and 4 are those numbers in order from least to greatest. So the next thing I want to do is map the relationship. So there we go. I mapped the relationship, and now I'm checking to see if each domain value only has one range number associated with it. So 1 checks out just fine. It only points to one number. 4 checks out fine. It only points to one number. However, 16, notice I've got two arrows going away from 16. That is a problem. The reason that this will be determined as not a function is because 16 has two arrows pointing away from it. What I'm saying here is that 16 is producing two different values. The input 16 is producing two different values, so that means that this relation is not a function.